In this video, we are going to see how this fraction containing a cubic term in the denominator has this partial fraction decomposition. And subsequently, we are going to solve for A, B, and C. So in order to appreciate this expansion, we are going to go through these three examples. So if you are given a problem, the first thing is to check whether the denominator is factorable. So I can factorize the term in the denominator and I will have s minus 2 and s minus 3 and I will have 1. So the next thing is to decompose the terms. So I will have s minus 2 plus s minus 3. So a key component of partial fraction decomposition is that the power of the denominator is always 1 greater than the power of the numerator. So the power of the denominator is 1 because the highest power is 1. So you know that s to the power 0 is just a constant, it's just 1. So I will represent it by a general term for a constant, which is, I can give it any term. So if I choose A, it's okay. Also, this one has a power of 1, so it means my numerator has a power of 0, which is a constant. So I can represent it by a general term for a constant, which is B. So if you look at this term, already I have s plus 1 and I have s squared plus 2. So this one is already linear and I cannot factorize this using integers. So I have to leave it as it is. So I will have s plus 1, s squared plus 2. So I will have what? I will have s plus 1. So also the highest power is 1. So it means I will have A. And then for the other term, I will have s squared plus 2. So for this one, the highest power is 2. So it means the power of my numerator will be s to the power 1. That will be the highest power in the numerator because always the power of the denominator is 1 greater than that of the numerator. So it means I will have bx, but I have to write it in general form. So it will be bs plus c. So because it has to go from the highest power up to the lowest power, which is s to the power 0. So moving to this example, you see I have s plus 2 and s cubed. So this time is already linear and I cannot factorize this further. So I need to decompose the two terms. I will have s plus 2 and then the other decomposition is s cubed. So if you look clearly, the highest power here is 1. So it means the highest power in my numerator will be 0. So I will just have a s to the power 0, which is just a. And here I have s cubed, which is a power of 3. So the highest power in my numerator is 2. So I have to write it in general form. So I will have bs squared plus cx plus d. So I can decompose this term further and I will have a over s plus 2 plus bs squared over s cubed plus cs over s cubed plus d over s cubed, and that will reduce into a over s plus 2 plus b over x plus c over s squared plus d over s cubed. So if you look clearly, I have my a over s2 and then the terms is like I'm just writing b over x, then the next power c over s squared, and then the next power d over s cubed. So it is similar with this example. I have a cubic term here, s plus 1 cubed. So to prove that it is the same with the expansion we just saw, we can just substitute t to be s plus 1. So it means our s will be t minus 1. So if we substitute it in this fraction, I will just have t minus 1 squared plus 4 into t minus 1 plus 6. Then I will have t to the power 3. So it will just be equal to t squared plus 2t plus 3 all over t cubed. So you see the highest power in my denominator is 3. So it means the highest power in my numerator will be 2. And writing it in the general form, I will have at squared plus bt plus c. So I can further decompose it, and I will have at squared over t cube plus bt over t cube and plus c over t cube. So at the end of the day, I will have a over t plus b over t squared and c over t cube. But don't forget, my t is s plus 1. So I can substitute s plus 1 and I will be able to get this decomposition. So since we have c, why we have this decomposition, let us then solve for a, b, and c. So to solve for a, b, and c, in my left hand side I have s squared plus 4x plus 6 all over s plus 1 cube. The LCM is just s plus 1 cube. So I will just have s plus 1 into s plus 1 cube. I will have s plus 1 squared times a. So I will have s plus 1 squared. Then s plus 1 squared into s plus 1 cube. I will just have plus b into s plus 1. Then s plus 1 cube into s plus 1 cube. I will have 1. So I'll have c times 1. So I just have to multiply both sides by s plus 1 cube. Here I will have s plus 1 cube. So this one will cancel, this one will cancel. And then I will have s squared plus 4x plus 6 will just be a into s plus 1 squared plus b into s plus 1 plus c. So it will be easier if I just substitute s to be minus 1. So I will have my a and b cancel. So let s to be minus 1. So it means I have minus 1 squared plus 4 into minus 1 plus 6. So I will just have a into minus 1 plus 1 is just 0 squared. Then I have b into minus 1 plus 1 is also 0. Then I have c. So if I solve that, I will have this part will solve to 3 and I will have c. So it means my c is just 3. So substituting c back into this part, I will just have s squared plus 4x plus 6. So let me expand this. So I will have a s plus 1 squared can be expanded to s squared plus 2x plus 1. Then I have bx, b times x. Then I have b. Then I have my c is already computed to be 3. So it means I have s squared 4x plus 6. So let me collect like terms. So for x squared, I just have one term which is as squared. So for x, the like terms, I have 2a from this part. So I will have 2a. From this part, I have only b, so plus b. Then for the constant, from this part, I just have a. Then from this part, I have plus b plus 3. So I can compare the coefficient of the left hand side and the right hand side. So if I take s squared and I compare it with the coefficient in the left hand side, you can see a is just equal to 1. So I have a is just equal to 1 and this will be my b. And then if I compare either the coefficient of x or the constant, I supposed to get the same answer for b. So if I compare the coefficient of x, so it means I will have 2a plus b is just equal to 4. So it means my b is just 4 minus 2a, but my a is 1. So it means I have 4 minus 2 into 1. So 4 minus 2, it means my b is equal to 2. So now I have my a, I have my b, and I have my c. So it means I just have b 1 over s plus 1 plus 2 over s plus 1 squared and plus 3 over s plus 1 cube. So if you want to learn how to solve simultaneous equation using Cramer's rule, watch the video on the screen. Please like and subscribe to the channel. Thank you for watching.